Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial on logical database design. This tutorial will be done in a series, so there'll be many parts. I'm not going to name how many because I may change my mind on the way along, but about a handful. This is a follow-on to a set of tutorial videos that I did for conceptual data modeling, and this is the second step in the process, logical database design. And what I have in front of you is a little diagram I created in order to organize my work on this. And this is my diagram of the process of logical database design. I just want to walk you through the process as a way of an orientation to the work that we're going to be doing. We begin with conceptual data model. Now this is the output from the process that precedes logical database design. And so the first thing that I want you to do when you begin your logical database design is make sure you have a product that is appropriate in terms of being a good conceptual data model. So the conceptual data model that we are interested in is expressed as an entity relationship diagram. And so in order to judge the goodness of it, you need to have confidence that the entity types on the diagram, the relationship types on the diagram, the attributes on the diagram, the identifiers that you have identified on the diagram are going to be able to support whatever application this data model is supposed to support. Okay? So in my last set of tutorials, I was using an example from a student attendance system that I've been designing for my students at the university who have to record their attendance. And I created a data model based upon that, and that's what we're going to be using again for this series of tutorial videos. And I'll go over that data model in just a couple of minutes. So the first of the step is to refine the conceptual data model. Then the next thing we want to do is we want to convert the attributes from the data model into columns for the relational database. At this point, we have made a commitment to using a relational database product. In my database courses, at this point, we're using MySQL. Okay, and so these things that were entity types before, as we turn the corner and turn it into a logical database design, they're becoming the tables of the relational database. And the things that we listed inside of the box that we had for the entity type, the attributes, now they take on a new life as a column in the database as part of the table. Okay, so the first thing we do is we're going to convert the attributes into columns. And to give you a little bit of overview of what we're doing there, we're going to select a data type for each of the columns. Then we're going to convert the things that we marked as identifiers in the logical data model. We're going to convert them into primary keys, a pretty straightforward transition. And then the other thing we're going to do is add further columns that are required to support the functionality that we have in our application. And the reason I raise this is not everybody puts in all of the attributes, or even some of the attributes, in a conceptual data model. There's wide variance of how many of the attributes are included in a conceptual data model. Whereas all of the columns are included, well, most of the columns, as we'll see later, but all of the columns are going to be included in the logical database design. So we have to make sure that we include all of the columns. So anything that we've left out that we need to support our application is going to have to be added. Once we have all the tables and all the columns, we're going to go through normalization. Now, this is a process of improving the goodness of a relational database design. So good relational database designs are said to be normalized, and there are a number of normal forms, which are kind of standards for goodness. And we're going to be trying to get our database in what's called third normal form. So we're going to learn how to do a number of things, and I'm just going to read them off here so you can start thinking about them. We're going to remove redundant columns from the tables. We're going to remove redundant relationships from the database design. We're going to eliminate columns that repeat on a table. We're going to relocate columns that we decide are misplaced. And then the very last thing is we're going to look for any free-form text fields that we could replace with a reference to a lookup table. Okay, so that's what we're going to do when we do normalization. The next thing that we're going to do in our logical database design is we're going to resolve the many-to-many relationships. In a conceptual data model, we allow the relationships between two of the entity types to be many-to-many. That's because some of the technologies that we might use to implement the model, things like graph databases, topic maps, RDF, these are technologies that have direct support for many-to-many relationships. Well, that's not true for relational databases. They don't. And so we're going to have to make some changes in the design in order to accommodate what we have in the model at this point are still expressed as many-to-many relationships. And the very last thing that we're going to do is add foreign keys. Okay, so the relationships from table to table in relational databases are implemented with foreign keys. Up until this point, some people have kind of talked about foreign keys, but we haven't said that you need to add them to the tables in order to make the relationships go, and that's going to be our very last step. So, are we absolutely done with database design? Well, no, we're not. What comes after logical database design? Well, physical database design. And that's going to be another set of tutorials that I'll be doing a little bit later. So this is the middle step, logical database design. And so you would be interested, well, what's the data model that we're using for these tutorials? And what I'm going to do is going to bring up an introduction to the application we're going to be using. So I mentioned a little bit earlier, the students at the university where I teach in the undergraduate program are required to sign into classes to confirm that they attended the class. I currently do that with sign-in sheets, which I'm not all that happy with. There's a lot of paper, a chance to lose things, all those kinds of things. And people have to stand in line to do it, even though we're teaching the classes in a classroom where everybody has a computer. So what I want to do is to build a student attendance system that will allow the students to come into class, log on, log their attendance into the system for that class meeting, and then that's it. Okay, so I've put together a use case diagram for those of you who've been involved in my systems analysis classes. You probably are familiar with use cases, but these are a way to express the functionality that's in a system, and it's a pretty simple diagram. The functions of this system are represented by these ellipses that are in the middle of the diagram, and each function that goes on is given a name, and it's called a use case. Each of these is a use case. So here we're looking at two: log attendance and generate student attendance report. So these are two functions that the system does for the student. And the page of the use case diagram that we're on is called student-facing use cases. So what is the student? What's this little stick figure out here? Well, this is what in use cases we call actors. And so this is a user of the system who's playing the role of student in working with the system. And what does the line say? Well, it just says that this actor role interacts with the system in the use case. So the student actor plays a part in log attendance, and the student actor plays a part in generate student attendance report. So what other use cases have we got? Well, we have ones that are instructor facing, and they're there to allow the instructor to set up the course such that students will be able to record their attendance using the system. So this is the instructor actor. There's more use cases on this panel of the use case diagram, and here's what they are. So create semester allows the instructor to create a new semester in the system. Create class allows the instructor to create a new class in the system. Enter class meeting schedule allows the instructor to identify the class meetings that are going to happen for a class. Enter class roster allows the instructor to identify the students who are supposed to come to each of the meetings. Enter class meeting password. I have this idea that you're going to be able to enter a password that I'm going to put on the board, and that's how I know that you're actually there. Now, I have some other ideas that this is kind of a placeholder for. But for right now, this is what's going to keep people honest. And then, of course, the instructor is going to need some output. So there are two more use cases for the instructor: generate class attendance report and generate semester attendance report. Okay, we've got just a couple of use cases left, and we call these administrative use cases. These are the use cases that are primarily for the care and feeding of the system. So everybody who uses the system, when they're using the system to do any of the use cases at all, are playing the role of system user, and they log in. Okay, and when they log in, then we know what other use cases they're authorized to do because of what's happened up in this other use case, authorized user. So let's look at this. So we've got a person who's we're playing the role of system administrator in that use case, and we have a person who's playing the role of system user. And I'm not really sure how the workflow is going to work. One potential workflow is the system admin could just identify all the users in the beginning and what they're authorized to do, and then this authorized user use case would inform the system user that they're authorized and they're ready to go. Alternatively, the system user could say, oh, I want to use this system and I want to use these functions, and then the system administrator would have to come in and authorize that. So one's sort of a push and the other's kind of a pull, but in terms of which roles are interacting with the use case, it's a combination of this system admin and the system user. So that's the system that we're trying to support. And let's take a look at the data model that we're using to support it. So I'm just going to pause here to get the right version of the data model up. Okay, and here I have the conceptual data model, which came out of our tutorial for conceptual data modeling. And it's a conceptual data model to satisfy the requirements of the application we just talked about, the student attendance reporting system. And this is how I finished that tutorial. And just to kind of walk you around. So what were the entity types? Well, they were student, instructor, semester, course offering. That's a course that we're collecting attendance information on. Class meeting, that's a meeting of that course that we're collecting attendance information on. And then down in the bottom, I've got system user, which has a relationship with either student or instructor. And then I have a permission scheme whereby I've got a particular system user has a permission to play a certain role. Okay, now I want to tell you that when we began working on the logical data model, you'll find that this conceptual data model has gotten worse. It has degraded. And that's because I wanted to show you an example of every fix that we might have to make. And the model's already a little too good for our purposes. Okay, so I devolved the model, and in the next of the tutorials, I'll be showing you the devolved version of it. But what I'm going to do is I'm going to go through and repair a series of improvement needs as I follow the methodology that I raised earlier, which is so here it is. So here's the methodology. So we're going to refine the conceptual data model. I'm going to consider myself to have already done that. The next of the tutorials, we're going to convert the attributes into column. Then we'll probably do a couple of tutorial videos to normalize. Then we'll have one where we resolve the many-to-many relationships. And our very last one is we're going to add foreign keys to implement the relationships. So I invite you to join us on the rest of this journey as we go through logical database design with our example from the student attendance system. I'll say bye for now.